Okay, let's get this definition down so I can erase. Today we're going to talk about probability and how that compares to finding odds. The odds of someone winning or the odds of something happening. I love how I go straight here and my arm just says, Do all of you have it? Because they can press pause. Okay. All right. Probability, the relationship between what we want to find out and the total quantity. Now, a lot of you already know about probability, and the others of you are going to catch on extremely quickly. Okay. The one I like to start with is okay. Here's a bag of marbles. Okay, here's a green and a red and a blue. Let's get this out of the way. And a red and a yellow and a blue and a blue and a green and blue and white. Okay. 1, 2, 3, 4, 5, 6. I'm good. Okay. All right. Now, if I ask you, what is the probability, if you didn't look in this bag and I actually untied it, you put your hand in there, but you didn't look. I want to know what the probability, and they're going to abbreviate it like this. The probability of pulling out a green marble. Okay, that's what this means. The probability of pulling out a green marble. Okay, so the probability, the way you're going to do it is you're going to find how many greens over the total. That's how you're going to find the probability. Easy enough, right? Okay, so let's count the greens. 1, 2. Do you see 2 greens? So the probability is going to be 2 out of the total that's in there. How many's in there?
9. 10.
I think there's 10. I think so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. And you don't leave it. It's like all the fractions that we've ever done. You still simplify your fractions. So the probability is 1/5. Okay, 1/5. Easy enough? Okay. Let's find one more time. And then we'll go a tiny bit further. Let's say, let's find the probability of a blue or a red. That means it can be either one of them. So, what do I have? How many blues do I have?
4.
1, 2, 3, 4. So, I have 4 out of 10 here. And the or, now we're going to have the difference between or and. Okay, or and. Do you need to move to another place? This is how I always have to zoom. When you see, let's go ahead and talk about or and. In probability, you're going to have an or. It'll say the probability of that or that. You're going to add the 2 probabilities. If you see an and or just a comma, then you are going to multiply the probabilities. Okay, keep this in mind, put it with your notes. So this is the blue probability, right? But it says or, so we're going to add those probabilities. And now reds, 2, okay, plus 2 out of 10, okay? And that'll give us 6 out of 10. And the probability when we simplify is going to be 3 out of 5. Yes? Do you think that's easy enough? Okay. And just to make a point, okay, now this says, what's the probability of getting a blue and a red? Okay, that's going to be harder to do, is get a blue and a red when I draw. So and or comma means that I need to multiply these, okay? And when you multiply those, you're going to get 8 out of 100 because you multiply the top and you multiply the bottom. So I have 8 over 100. I can divide the top and the bottom by 4. And I get, there's 2 chances out of 25 times I could draw. And only 2 times I would get what I'm wanting here. Okay. Now I'm going to give you an overview of a lot of things. Like when I said this, it was that I was asking the probability of reaching in there, and I get a blue, and I go, oh, yes, and replace it. Okay, they're going to use the word replace or not replacing. Okay, we'll talk about that in a minute. But I pulled out a blue and said, yes, and I put it back in, and I replaced it back in the bag and drew again, and I actually got a red just like we needed to. And you know that that's harder to do, right? And that's why we multiplied here. Now, let's do this one. We're going to do the same thing. This was, I'm going to say this was replace, okay? That's when I pulled one out but put it back in the bag. This time, let's do it where we don't replace it. I drew the first one out, got a blue, and I laid it aside, okay? If I laid it aside, what changes here? Okay, the blue, the comma means I'm going to multiply, right? The blue is 4 out of 10, right? Okay, but I took a marble out and left it out. Now, if I took out the blue and left it out, how many reds are there? There's still 2, right? But how many total are in there now? 9. So you're still going to multiply, but you're going to use different fractions here depending on whether you replace or you don't replace. You take it out and leave it out. Yes? Okay, and so this in this instance, we're going to have 90. We can't divide by 4. I don't think, no. Can't divide by 4, but we can divide by 2. So to simplify, and remember, the calculator will do that for you. All right? Let's do this one. Okay, stay with me. Are we okay? I mean, you're okay with everything I've done so far? All right, let's do this one. Did somebody say something? Do you need calculator?
Me too.
Okay. Get your pen.
the 8th, huh?
It is the 8th. Yes.
And then that's the number. Since you write on there.
Well, if you'll notice on the first page of the packet I handed you, the first page is backwards. It's the answer sheet.
Oh.
So I put it on there backwards. Looks like the others are okay. Silly me. All right. Okay, this is not, not going to replace here. So this says, what is the probability that if I put my hand in there without looking and I pulled out a blue, I left it out, and what's the probability that the next time I put it in there, I will get a blue again? Okay, the comma or the word and means, what are we going to do? What? Multiply, yes. Okay, so let's look at the first one. What's the probability with this whole bag getting a blue out of there? It is 4. Yeah, I have to count myself. 4 out of 10. That's correct. Now I'm not putting it back in. Put it over here. Now, what is the probability of getting another blue out of that bag? 3, because I left one out. So it's 3 out of 9 now. Y'all see? Okay, so you've got to be careful and read in the problem whether they're putting the stuff back or whether they are leaving it out. And so in this case, we're going to have 2, 5, so we have 2 over 15. Or you could multiply across and then simplify, either one. I cross cancel. I like to cross cancel. So that's the probability. Right? Now let's move on from marbles. Any questions here? Oh, I see some people now.
I don't understand how you got the 3 over 9.
Okay. Let me let them in real quick. Okay. The 3 over 9, when I was looking for the first one, I counted 1, 2, 3, 4 blues out of 10. But I then, when I took that blue out, I didn't put it back in. So now I want to know what's the probability of getting a blue again out of that bag. And it's 1, 2, 3 now.
How did you take it out though when you got 4 over 10?
Because I said I'm not going to replace the first one.
Oh,
Okay. Okay. Yes, I like when you guys do that, because it's either I skip some stuff that I go too fast, or it's probably a question everybody else has. So keep it up. Questions are good. Hi, guys.
Good morning.
I put a couple of definitions, short definitions up at the first of this recording. So you'll want to look at the YouTube to get those definitions, okay?
Yes, ma'am.
Sound good?
Yes, ma'am.
Good. So nice to see you guys again. Remember, Sherry, you're going to take it off of speaker view, right?
Oh, yes.
So it doesn't keep popping around on you.
Yes.
Okay. All right.
And those numbers, I'll say, like number 2 and 1 and 5. How
Oh.
do you get those?
Okay. That's called cross canceling, and I'll show you. It's when I like to, it's simplifying fractions, but doing it in the problem. Okay, the first one was 4 out of 10, right? And then 3 out of 9. Okay, here we go. So when I have a multiplication problem and it's all fractions, if I don't want to get a big O numbers and then simplify, I would rather cross cancel. Now, what you're looking for is any top with any bottom. They don't have to be on top of each other. It can be this top and this bottom, or this top and this bottom, or it can be this top and this bottom, okay? Any top with any bottom that divides by the same number, okay? So in this case, I said, well, 4 and 10 will divide by 2. So 4 divided by 2 is 2, and 10 divided by 2 is 5. And then I said, is there more? So I looked over here, and the 3 over 9 divides by 3, both of them. So I divided by 3 here and got a 1, divided by 3 here, because you have to do the same thing, and got a 3. Now, sometimes this is a big mess for students, so I suggest that they circle what they're left with, and it's easier to see them, see the numbers. When you run out of things, see, these won't divide by the same thing, these won't divide by the same thing, these won't, these won't. So you're done. Then you multiply across. And so we have 2 times 1 is 2, 5 times 3 is 15, and it's already simplified for you. But either way is fine. Okay, does that make sense? Okay. Okay, let's move from the bag of marbles. You're going to be, the paper that I gave you, the packet, looks really thick. I think there's 15 or 16 pages. But if you'll notice, there's only 3 or 4 questions on each page, and they're trying to move you slowly into the different types of probability problems. So let's look at the first page and just talk about it. I don't know if I want to draw that whole spinner up here. So I will put it, we are here, and you should have received this packet in your email. This was the front page. And I also noticed this morning that I put the front page on backwards. So your answers are right here. All the others I think are okay. So you can switch this around if you want, or ignore the answer until you look. Okay?
Okay.
Here's the spinner. And everybody in the classroom has this, so I'm not going to draw it on the board. So those of you watching a YouTube, just pause and copy it down. Okay. We're going to do number 1. It says, what is the probability of choosing an odd number? Well, at first, some people that come into my class are mixed up on odd and even numbers, and that's okay. That's what we do. You know, I take care of everybody. So let's just put them up so you can look. Odd numbers are like 1, 3, 5, 7, 9, and so, okay? And even numbers are like 2, 4, 6, 8, 10, and so on. They skip by 2s, okay? The odds, I don't have a funny story in remembering that. You just have to memorize those, okay? Now, the first question says, and you'll need to look at your paper, says, what's the probability of choosing an odd number? So you're going to look all through your spinner and find all of the odd numbers. You count them and I'll count them and we'll see. 1, 3, 5, 6, 7. I think I got 10. Me too. Okay. So now we have 1, 2, 3, 6, 7. So is the total 16? Okay. Okay, so getting an odd number on this spinner is going to be, okay, we need to do this. Probability of getting an odd number. This is the type of thing you're going to see. We found 10 odd numbers, and the total numbers on this spinner were 16. And then if you use your calculator to simplify, or you divide by the same number, we're going to divide by 2. And you guys stop me right now, especially Sandra. Yeah. And find out how to do this on your calculator. Okay? And so, of course, the answer's right there on your page. There's 5 chances out of 8 that if you spin that thing, you're going to get an odd number. Okay, 5 chances out of 8, which is pretty good. Pretty good. Okay, and you know how to find the simplified fraction, or do I need to show you?
You probably need to show me.
Okay, turn it on. Okay, now you can put a fraction in either way. You can either put in the 10 and hit the divide sign because this line means divide. And
You mean the inner?
you'll put 10.
Uh-huh.
Here, let me come there.
Oh, this one.
Yes. Okay, divided by 16. Go ahead, I can look up something. And then enter. Now you're going to get a decimal, and that's not what we want. But this is the magic button. This toggle switch will go to a fraction.
Remember that's, oh yeah, we're 5/8. Okay,
And if you said, nope, I needed a decimal, you can toggle it again and then go back to
to
the
the
decimal.
decimal.
Now the other way to put the fraction in is right here. And the students like this. And so let's clear it.
And you showed me that
Start with the 10,
10,
then hit that.
this one.
Mhm. See? Oh, and 16, but you have to scoot over. Scoot over. Because you have to get out from under here. Okay, now. Okay, there's lots of little tricks, and if I don't explain them well, these girls know how to. Okay. All right, so let's say, let's do this. What is the probability of getting an odd or an even? It's not on your page. I made it up.
So I was like,
What does or tell us we're going to do? What are we going to do, Brandy? Look.
times. Oh, yeah.
Or
Times.
Or plus,
Adding.
we're going to add, okay? The or we're going to add, right? So we found 10 odds, right?
Mm-hmm.
10 out of 16. And if it says or, then how many evens are there?
6.
There better be 6, okay? 6 out of 16, right?
Mm-hmm.
And we found out back in fractions that if you're going to add fractions, you have to have common denominators, and we do. So when we add, we get 16 out of 16. Why? This is like one whole spinner. Why? Because that's all that's on the spinner, right? Odds and evens. And so your probability is actually 1. That means the whole thing. Okay? What if we said and? Like we spun it and we got an odd. Okay? So we got an odd. And then we spin it again and we have to get an even. But the even is 6 out of 10, right? Okay, but it's harder to do that. To get an odd and make sure you get an even the next time. The and says to do what? Multiply these. Let's try to cross cancel, Mary. Okay? All right. You can choose any of them you want because all of them divide by 2, and I'll show you. Let's go across. This will divide by 2 and this will divide by 2. You could choose these. That's fine. But I'm going to show you that this works too. So if I divide that by 2, I'm going to have a 3. And if I divide this by 2, I'm going to have an 8, right? Well, it looks like I've got some more stuff. Nothing will divide by 3, but the 8 divides by 2, and so does the 10. So I'm going to divide these by 2 and get 5. And 4. Is there anything else? The 3 and 4 don't divide by the same thing. 5 and 16. 5 and 4, 3 and 16. No. So now we multiply across. And we get 15 on top and 64 on the bottom. Okay? So it's a lot harder to get them in the order that it says than the or. You know, you can get this or you can get this. Doesn't matter to me, right? Let's look. That has to do with spinners. And what I was going to tell you is I gave you a lot of pages because some of them deal with coins. Some of them deal with cards that have numbers on them. Some deal with flipping a coin, you know, days of the week, numbers on a piece of paper. The one that I want to talk about, a lot of my students in the past, I found out that when there was a test question about the probability using a deck of cards, that a lot of students have never played cards. They don't understand the deck of cards or what's in a deck of cards. So I'd like to go through that really quick and show you a deck of cards, okay? How many, have all of you played cards? I mean, you know about shuffling, okay, that's what I thought. Okay, so when you buy a box of cards, there are 54 cards in there. But when there is any kind of problem about probability and cards, 2 of these are what they call the joker, and probability doesn't deal with the joker. So when they talk about how many cards there are in a deck of cards means this stack, okay? Then they talk about 52 cards, okay? They don't count the joker. So there's always a total of 52 when you're dealing with probability in cards, okay? Then these are divided up into suits, okay? There are 4 suits in a deck of cards. One is hearts, and all of the cards have a heart on them. Some of them are diamonds, and they have a picture of a diamond on them. And then we have spades, and it looks like an upside down heart. And then it has something coming out, okay? Spades, clubs, right? And clubs, like this, I think. Okay, it's good enough. Okay, and so if you divide 52 equally, how many hearts, how many diamonds, how many spades, how many clubs are there?
10, I think, in each.
Take your calculator.
Divide it. Divided by 4.
Yes. How many cards are in each suit? 13. There are 13 in each suit. So there's 13 hearts, 13 diamonds, 13 spades, and 13 clubs. Okay? Now, those 13 cards are the same in every suit. They just have different colors and they have different pictures on them. Okay? The one thing I want you to know right now, this is very important. The hearts and the diamonds are red cards. They'll talk to you about red, okay? Those are red cards. So how many red cards are in a deck of cards?
26.
There's 26, because here's some red ones and red ones. These are black. Okay, so there's 26 red, 26 black, okay? Now, each one of them has individual cards. This will start with a 2. It's a card. It'll be something like this, and it has a heart here and a heart here, and it something like this. The cards look kind of like this. Okay, they have the number 2, but then 2 hearts on there. Okay, it's called the 2 of hearts. And they will have a 3, a 4, a 5, 6, 7, 8, 9, 10. They also have one, these are called face cards, a jack, a queen, a king, and an ace. Okay, this is a jack. Sounds like we're going to play poker, doesn't it?
Oh, yeah.
But they keep asking you stuff like face cards and how many red kings and that kind of stuff. So you need to know what we're talking about, and it might not hurt you to get a deck of cards and look at them, okay? But this is called a jack, and it has like a royal face on it, you know. All of them do. This looks more like a jack, and this looks like a queen and king. The ace doesn't have a face on it. It has a great big, it has a great big either heart or spade, or I keep wanting to say clover, club. And these are called face cards because they have faces on them. So think of this, because they'll do this. How many heart face cards are there in a deck of cards?
13. Oh,
No.
10.
Face cards,
Face cards. It
hearts.
should be 10. 9.
3.
Face cards, hearts. Yes, Josh. Hearts, just here. Face cards, 3.
Those are the face cards?
These are the face cards because they have faces on them.
Oh, ace, it just says 8.
I used to think that was a face card.
That's what I got, too.
I will look it up for you.
Okay.
But I thought face cards have faces on them, you know, and an ace didn't have a face. But it sounds like face and ace.
Yeah.
So listen to this one. You have to be careful when you're working with deck cards. How many face cards are there in a deck of cards? You had that a minute ago.
13.
No,
No,
try
9.
again.
12.
9. Because right now we're not counting the ace. Josh, did you always count that as a face card, the ace?
No, but if you're counting the face cards in the whole deck, you got 3 in each. 3, 6, 9, 12.
And the student has surpassed the master. Okay, you are absolutely correct. There are 3, 3, 3, 3, so not 9, it's 12. Thank you, Josh.
Mm-hmm.
Thank you. This happens to me every week.
It's a
Okay.
Monday for sure.
So how many, okay, sometimes they talk to you about how many kings. How many kings are in a deck of cards?
4.
4, okay. And how many red kings?
2.
2. Do you get the idea? Okay. So they have all of these in diamonds, all of these in spades, and all of these in clubs. Does that help you? Because in the worksheet, you will have some that have to do with the deck of cards. Okay, and I just want to go through, there it is. Yeah, okay, y'all can handle that. Let's talk about coins. Coins, pennies, nickels, dimes, it doesn't matter. You're gonna flip some coins. and it says a fair coin, which means, you know, they load dice and they load coins, but we're talking about fair coins when you read the instructions. And it says, what if one coin is flipped? Okay. Now, they're going to ask you to list the outcomes. Okay. Instead of just finding the probability, the very first ones say list the outcomes. So if I flipped one coin, what are all the possible outcomes? It could either become a head or it could be a tail, right? So there's only two possible outcomes. So they're saying this is like the total that we had with the marbles. Okay, this is the total. And then they say, what's the probability of getting a tail? What's the probability? Here's your whole bag. One out of two. Okay, do you see? Yes? Okay, so now it says, what if I'm flipping two fair coins? I need to know all of the possibilities that could happen. Okay, I'm going like this. Then I'm flipping them. What's all the possible ways they could land? Okay, heads or tails. And they include this. Or the first one could be tails and the next one be heads. Okay?
It could even be heads, or toes.
Heads, and tails. You are exactly right. So that's our bag now. That's the total number of outcomes that could happen if you're flipping two coins. Okay, so what's the probability of getting heads? Okay, probability of heads. How many of this is in that bag?
1 out of 4.
There's just one, right? There's one time that it would happen out of 4, right? So one chance out of 4. Because I'm looking at each outcome, there's 4 outcomes, and that's the only one that matches. Are we good?
Okay.
So what is the probability? Listen to this one, and I don't know how to write it. Let's just do this. What's the probability that when I flip these two coins, that they land and they match?
1 out of 2?
No, go ahead. You were saying it.
1 out of 2?
Didn't you say two first?
Yeah.
Because these landed the same, these landed the same. So there's 2 chances out of
2. 8. 4.
this is 1. This is 1, this is 1, this is 1, this is 1.
4.
Okay. Which simplifies to 1/2. Y'all get it? Okay. But this one, we hadn't talked a lot about. What are all the outcomes? And they're going to ask you on these. Find the probability, blah, blah, blah. If they say all the outcomes, you're going to do all this. Okay. Let me see. Okay, days of a week. They're saying stuff like, what's the okay, here's the days of the week. Do this in your head. It says, what is the probability? I bet she's been there for a while. Sorry, Isabel. Okay. Isabel's coming in. It says, what is the probability, days of the week, of selecting a day that starts with the letter S?
2 out of 7.
That's right. 2 out of 7 because we got Saturday and Sunday, right? So 2 out of the total days of the week. I think you all are getting the idea of this, right? Okay, we'll do some more and we'll pick up anything that was causing confusion in that packet tomorrow. there is a little bit on there, not a whole lot, but it asks you what are the odds. Now the odds work a tiny bit different. You still have to count. You still have to know total. Okay. So let's say the girls basketball team, okay, in their season, they played 24 games, okay? And they won 16, okay? What are the odds? How do they say that? What are the odds? Something about what are the odds of the wins to losses? Okay. What are the odds of the girls' wins to losses? Wins to losses. Okay. In this case, you're not going to put it on the total. Now, what are their wins?
16.
16, right? And when we do odds, we write it with a colon. Remember when we were doing ratios and proportions and we said 16 to something? It's the same as a fraction, but this is how we write odds, okay? Now, the question was, what are the odds of the girls' wins to losses? Wins to losses. Do I put
16,
24 here? No.
8.
They
16.
do what?
16. 20. No, 16.
8.
That's what they won, okay?
Be 16 to 8.
There we go. 16 to 8. And again, you even simplify this. It's like a fraction, so divide both of them by whatever. There's a big number, but if you don't know, then do both of them divided by 2, and you'll get 8 to 4. And you can see both of those will divide by 4, and so you get 2 to 1. Okay? These are odds, and they will tell you odds of, they'll tell you what they want for you to put first, and they'll tell you what they want to put second. And it's not always just the numbers that they give you in the problem. You have to figure out what they're wanting. Okay, there are a few problems right at the end of this packet that have to do with odds. So make sure when you read the problem, you're not seeing probability, you're seeing odds. Are you guys okay with this and ready to try it?
Oh, yeah.
Okay. I like how Josh always goes, oh yeah, everything's fine. I like it. I like it a lot. Any questions? Sherry, I haven't heard a thing from you.
I'm just taking it all in, Miss
Are
Deborah.
you? Are you? Okay, there was what, blah, blah, blah. At the very first, I put a definition of probability and odds on the board. You might want to go get that. Yes, ma'am.
The first page, the third one is what is the probability of choosing a prime number?
Oh, prime number, and you don't know what a prime number is. Okay, a prime number, this is a very good question. On the first page of the packet, I had a question here that it talks about prime numbers. And prime number is simply a number, they're usually pretty small, but it's a number that you can't divide it by anything except for one in itself. Like, if we have 6, we can break that down to 2 times 3, right? So 6 is not prime. But if we had 5, there's nothing that makes 5 except 1 and 5. So this is prime. I'll give you some other examples. This is actually called a composite number because it's not prime. We only have primes and composites, okay? Prime, how about there's 3. 3 is a prime because it won't break down. 4 will break down,
Or is
so
it kind of like the odd numbers or the prime numbers?
I think so. I don't think there's any even because they'll always divide by 2, right? Except for 2. 2 is a prime and 1 is a prime. But yes, most of them are going to be odd, but that doesn't mean all the odds are prime. We can have like 17 is 1, 19 is 1, 29.
11.
I think 57, nope. 57 will divide by 3. Maybe 59. Those, you understand what they are now? Okay, all right. Any other questions? I look over at the recording and my hair is just. Any other questions?
No, I'm good.
Did you get the worksheets that I sent last week?
Yes, I did.
Sherry, did you get them?
Yes, ma'am.
Okay. Okay. Well, I'm done for today and I'm going to let you guys try it. And tomorrow we're going to talk some more about probability, but we're going to talk about what are they? Permutations and combinations. But good news, there's a place on the calculator that does your work for you on permutations and combinations and factorials. Okay. So we're going to deal with those tomorrow and answer any questions that you hit on these 16 pages today.
Are you
Any
gonna,
questions?
are you gonna, are you gonna stay on after you turn off the recording?
I can if you need me to.
I have a question for you that doesn't have to do with probability.
Okay, well, I'm going to turn off the recording now